Okay. Hi guys, my name is Jawad. I am presenting learning hierarchical models of complex daily activities for annotated video. So the problem that we are trying to tackle is that having a video of a fairly long time, we want to be able to detect activities in that video, but not just one activity at any one point, but rather a hierarchy of activities at different granularities of the video. A classic naive approach to this would be to take each of those videos at different granularities, learn a classifier for them, and try to detect it. However, that has problems because there's going to be a high correlation between the classes, as well as there is no notion of parent-child relationship capture if we individually train each of those activities. So instead, what we decide to do, and this is common enough in this field, is that we'll learn classifiers for the low-level actions, which is the bottommost layer of actions. These are short actions. They're fairly easy to learn. And then given a stream of those actions, we're going to try and infer the high-level actions that comprise of those actions. And this goes on to build multi-level hierarchy to an arbitrarily high depth. So the question is, how do we learn a hierarchy of an activity? That is to say, which activity is a child of which other activity? So the main insight that we noticed is that different people tend to describe activities at different levels of granularities. So we asked a lot of people to annotate videos and free label them. We didn't tell them anything about what to do or what not to do, just to identify an activity label, start and end time. And what we noticed is that they were able to identify different activities at different levels. So we want to exploit that to learn the entire model. So the way it works is that we are going to have multiple annotators annotate a video. We'll gather all their labels together. First of all, we'll try to cluster the labels because a lot of people are going to describe similar activities repeatedly. So we clustered to get rid of those similar activities. And then having a hierarchy for each of the videos, we're going to combine them into a general hierarchy of the whole entire video. We're going to detect the low-level actions, and then using the hierarchy that we just learned, we're going to infer what the high-level actions in the videos are. Okay, so clustering labels for annotation we use agglomerative clustering, which is sort of like a hierarchical clustering with complete linkage. The important thing here is that we use a distance metric to define the distance between any two labels based on their start and end time, so that should be similar. But at the same time, their linguistic label used should also be similar. So we use natural language processing techniques to find the similarity between the language of the labels so that we can combine activities that are similar whilst keeping apart the activities that don't really have anything to do with the ones that we're clustering. Once we have that, now we want to learn the parent and child relationship. So we devised this metric, this cost function, that is going to look at the overlap of the activities, and it's going to assume that an activity is a parent of another if it overlaps it in time. But at the same time, similar to the clustering, it has a high amount of correlation between its labeled set and the child that it's trying to be a parent of. If we do that for all the labels we have, we come up with this sort of hierarchy that's on the left side. And the thing we do next is that we augment this hierarchy with Allen's temporal algebra, which is a commonly used qualitative method of encoding temporal sequences of activities to produce a hierarchy that looks the way it does on the right. Having multiple hierarchies from different training videos, we can now combine them using a commonly used parsing mechanism in natural language processing to build an extended grammar representation. However, the important thing here is that our grammar has not only the left-hand side, which is the sequence of terminals, but also a right-hand side that is a matrix of the relationship that encodes the time sequence of those left-hand side. Right, now to infer the high-level activities, we take our final model, we figure out what the lowest level actions are, and we can use those to train an SVM to detect the low level actions. Given a test video, we will detect the low level actions from the test video, and that low level action stream, it says complex is because it has multiple overlaps and it's not really one after the other. We use that to then parse using the grammar that we just learned, all the high level activities, and we get a high level tree like that. That is our full activity hierarchy inferred. Here are some results. So we see that we perform fairly well across all three tasks that we set out to do. We use 3 datasets, CAD, LAD, and CLAD. And here are some example hierarchies. It can be seen that they are fairly reasonable in what they detect. Thank you very much.